Alright guys, welcome to our Unit 7 Quiz 2 Study Guide. Let's go ahead and begin here. So number 1 says find the area enclosed by the function y equals e to the x plus 1 and y equals x plus 3. Show the integral and use the calculator to get your answer. Alright, so this is worth 2 points. And one of the points is, are you able to actually set up the integral? Alright. The other point is getting the correct answer. So let's go ahead here and begin by using our calculators. Once again, make sure you guys follow along these steps with your calculators there at home. If you don't have one, you can download an app on your phone. You might even find a free app. You want to find one that kind of looks like the calculators that you guys use in class. So we're going to go to y equals, and we're going to type in e to the x plus 1. For our first function, and our other function was y equals x plus 3. I'm going to go ahead and push graph, and we have a nice view here already, so that's nice. We don't have to adjust our window. Let's go ahead and push second and calc, and number 5 to find out where these lines are intersecting. So I'm going to call this one where they're intersecting over here on the right B. So we're going to push 1, 2, 3. And so it's intersecting at 0.146. So I'm going to save that as B on my calculator. Now you don't have to do that, but it'll give you a more accurate answer. But a way that you can kind of get around that is that if you want to just write it down so you don't forget it and not have to store it, you can just write down, I would say, at least 4 numbers after the decimal, because you want your final answer to be accurate to the 3rd decimal place. So if you go out 4 here, the error will only be on the 4th number and not on the 3rd. So there's that. So let me go ahead and store that now. So I went ahead and pushed store, and then I do alpha, and I'm going to call that one B and enter. All right, back to the graph, and we'll find the other intersection point. So second calc 5, scroll over to this point on the left where they intersect, enter 3 times. So the other place where they're intersecting is here, so I'm going to go ahead and push enter again, and then store, and then alpha A. So I'll call that point on the left A. All right, so we have our points there. Now we're ready to go ahead and write out our integral and solve. So here we go. So we're going to do our integral. So it's math 9, and the A was the one on the left, so that comes first. So negative 2.841, right? So, but I'm just going to type A there. If you're not storing, you could just type the actual number in there. But remember, go out to at least the 4th number. All right, and then alpha B goes on top. And then we're going to go ahead and put our functions in there. Now, what you could do is, if you forget which one's on top, you can just use absolute value bars, or you can just look back at your graph and see, if you push trace here, and you just trace along. Right now I'm tracing the blue line, so you can see that the blue line is the E function. So it looks like the red line, the x plus 3, is on top, and the E function is in the bottom. But like I said, if that's all confusing to you and just don't want to go back and look at it, you can just use absolute value bars. It looks to me like I stored the x plus 3 and y2, so I'm going to put y2 first. So bars, and minus y1, and enter. And there's my final answer. All right, and there's our 2 points. So you get 1 point for the setup, and you get 1 point for the answer. Okay. Now, a few notes about the setup. If you did do the storing of the values, don't write A here and B here, the actual letters. The only time I would recommend doing that is if on the side you're going to tell me what A is and what B is, because if you just put A and B there, I'm not going to know if you know the actual numbers or not. So you have to actually either define them, and then you can use them here, or you can just write them in here, and that's what I did, because why would you define them if you're going to have to write them out anyway here. So also, I would recommend using brackets to encompass the whole thing, and then a separate set of parentheses for each one of these here. Now, if you want to be safe, and quite honestly, I would encourage it, is just to make sure, just put absolute value bars. That way I can't fault you. If you accidentally write these in backwards, it won't matter if you have those absolute value bars, but if you don't, then you're going to be wrong. So if you don't have them in the right order. So make sure that I would use them just to be safe. Okay, so let's go ahead and move on to number 2. All right, so this one says find the area enclosed by this function here and this function here and then these two. Now these two are special. These are basically, you'll have some problems where they tell you where to start and stop. So this would be the starting point for our integral, and this is going to be the stopping point for our integral. Sometimes they'll do that if the two functions don't intersect at all, or sometimes they'll do it just because they don't want you to find the whole region between their intersection points. They don't want you to find a certain part, and so you will have some problems like that. So that's it for it. So let's go ahead and turn to our graphing calculators here and plug in these functions. All right, so there they are typed in, and just as a reminder, when you're doing fractions like the one here for y1, if there's more than one term on the top, you need to put them in parentheses for both the numerator and also for the denominator. Okay, so let's go ahead and push graph and see what we can see here. Now it turns out that these two functions actually do intersect, so they cross here and here, but we really don't care because our problem only wants us to integrate from 2 to 4. Okay, so what does that mean? Let's take a look. So here's where 2 is, so I'll draw a little line here, and up to 4 is here. So they only want me to find the area of this region here. They only want me to integrate from x equals 2 to x equals 4. They don't want the whole area that they're encompassing there. And so that's an important thing to keep in mind. So let's go ahead and go back to our home screen here and actually find the integral. So just to help you with the keys, we push math, 9, and that brings up our integral. And we're going from 2 to 4. And then our functions, I'm going to put them in absolute value because I forgot to look at which one was on top. So I'm just going to go ahead and push math. I'm going to scroll over to num. I'm going to click 1 for absolute value. And that way it doesn't really matter which one I put in first. And I get 5.961. And we're going to round this 1 up to a 2 because the number after it is bigger than 5. All right, so notice I put absolute value bars because I wasn't really paying attention to which one was on top. Also, I have my limits here, 2 to 4. Notice that I put one function in parentheses and the other function in parentheses. Now, what you could do if you want to is, you could define which one you want to call y1 and which one you want to call y2, and then instead of actually writing the functions, you could put y1 and y2. But quite honestly, I just prefer if you guys do it this way, therefore it's less ambiguous. But if you don't actually, if say you're on an FRQ, and on the AP exam, if you just put y1 here and y2 without specifying which one is which, they're not going to give you any credit for that. So you have to make sure you actually define them. But anyway, once again, the points are distributed by, you get 1 point for setting this up correctly and 1 point for actually being able to calculate it correctly. All right, let's go ahead and take a look at number 3. It says find the area between the y-axis and this function here. Okay, now the equation of the y-axis is x equals 0. Okay, and over here, this function is x equals also. So you're noticing that we are integrating with respect to y here. So whenever we're integrating with respect to y, The values that go here are y values, and these functions are functions in terms of x. Okay, so I already know my function's going to look something like this, at least. We're going to have one of my functions here, and then the y-axis, like I said, that's just x equals 0, so that's going to be 0 there, and then I'm going to put absolute value bars on it like that. Okay, put parentheses around my functions. Once again, it's a little bit extra. Honestly, the minus 0 is not even needed, right? Because if you subtract 0, that's like nothing. So you can write it this way, and I think that's fine. But you could also technically not be extra, and you can just do that. That would be fine also. It doesn't really matter. But don't forget to put your dy there. Now, the only thing I need to do before I can actually calculate this, though, is I got to figure out what these numbers are. So I need to basically find out where this function touches the y-axis. Okay. Now, the problem with that is that we're used to doing it by graphing, but our graphing calculator doesn't graph functions of y. It only graphs functions of x's. So what we're going to do for our calculator is we're going to just pretend for a minute. Don't write this down. I'm just writing it for you guys to look at. But for our calculator, what we're actually going to type in is this. And instead of looking for where it crosses the y-axis, we're going to look for where this crosses the x-axis. So I'm just changing the variables. That way I can actually do the problem on my calculator. Because my calculator, once again, only does functions of x. So let's go ahead and turn to our calculator and do that. All right, so let's get our square root going here. So second, and then there's the square root. It's going to be 4 minus parentheses, and then x minus 2, close parentheses squared, and I believe that was it. So let's go ahead and graph it. And now basically I want to find out where does this thing touch the x-axis. Now, one way that you can find where it touches the x-axis is that you could actually just go ahead and graph the other one, which is 0, right? And then you could just, so now see they've got a red line here. That's the line y equals 0. And you can find where the red line touches the blue line. I'm going to go ahead and do that for today. But we've done it in another way in the past. But anyway, second, calc, let's go to 5 for intersect. And we're going to do 1, 2, 3. And it intersects at 0, 0. Now, I'm not going to store that. That's easy enough to remember. Let's go ahead and repeat that process to find the other place where they intersect. Oops, where'd it go? There it is. All right. 1, 2, 3. Oh, and this will happen sometimes. So just so you guys know, sometimes the calculator has a hard time finding where it hits the axis if that's where the function stops. So for instance, this blue line here actually stops right where it touches the red line, and that sometimes confuses the calculator. So when that happens, I say just go ahead and eyeball it and take a guess. Where do you guys think it touches the x-axis? Well, it looks like it's touching the x-axis at 4. So we have 2 spots where it's touching the x-axis, 0 and 4. And so those are going to be our integral limits. Now, I'll remind you guys of the other way to find out how a function touches the x-axis, just for the heck of it. If you're not interested in watching, you don't have to, but it actually, you know what? I won't do it because it'll have our calculator just have a hard time with it once again. So I'll skip that for now. So this is a good way to do it for today. All right, let's go ahead and put down our thing now. So we had this, and we just figured out that our upper limits and our lower limits were 4 and 0. And so now we want to go ahead and actually calculate the integral value. All right, so let's get back to our home screen, and I'm going to push math. I'm going to do 9. I'm going to do 0 to 4, and I'm going to put my function in there. So that'll be bars y1 minus y2. Now I should have put, oh, that's not the right thing. I should have put absolute value bars. Maybe I'll get lucky and still get the right answer. Let's see, I'll show you what I mean by that. So here's the thing. If you forget your absolute value bars, here's what's going to happen. You're going to get the right number, but it'll just turn out negative if you got them put in backwards. So just be careful with that. Now, the only time that's not true is if you ever have functions that are intersecting in more than one or two places, then you'll actually get the completely wrong answer. But these two functions are just intersecting in two places, so we're safe. But there it is. 6.283 would be the final answer for that one. So 6.283. And once again, you're getting 1 point for the integral and 1 point for your final answer there. So the little twist on this guy is that you have to remember, okay, we're integrating with respect to y, so this is how you'll set it up. But on your calculator, you're just going to treat all the y's like they're x's, just so our calculator's happy. Right? Let's go on and move to another problem. All right, so for number 4, it says write an integral with respect to x to give the area enclosed by the functions. And then it says write an integral with respect to y to give an area enclosed by the functions. Okay, so let's go ahead and begin here. Now, just so you guys know, for these problems, we're not actually going to calculate the area. We just want to write the integral. That's all there is to it. So, but it's still worth 2 points. So I'll show you where those points go in just a second. But for now, let's go ahead and graph it. So we want to graph 3x and x squared. 3x and x squared. So let's clear out our last stuff there. There's that. Let's go ahead and graph it. There they are. And so this is our function that we're graphing. Now we're going to find where they're intersecting, but this time we're going to do something a little bit different than we did last time. We're actually going to look at the x and the y values. Okay, so because whenever you do an integral with respect to y, you want the y values, but when you do an integral with respect to x, you want the x values. And since this problem is asking for both, then we need to get both of them. So second Calc 5 and 1, 2, 3. The first intersection point is at 0, 0. So let's go ahead and write that down so we don't forget about it. Go ahead and find the other intersection point, second Calc 5. We'll scroll to where they're crossing, and then 1, 2, 3. And the second point where they're crossing is 3 and 9. Okay, and so now we're ready to go ahead and start writing out our integrals. Now, it might be helpful to remember what this picture looks like. So when you're doing an integral with respect to x, it's top minus bottom. But when you're doing an integral with respect to y, it's right minus left. So for the integral with respect to x, the blue line will be the one that we will write first in the integral. And when we do our integral with respect to y, the red line would go first. But once again, you can avoid all that confusion if you just want to slap some absolute value bars on it. Okay, so let's go ahead and write out these integrals here. So let's first of all begin with respect to x. So we're integrating with respect to x. And I know that my blue line was the straight line, and so that's the 3x, and that would go first. And then my red line was the x squared, so that goes second. Okay, so there's that. But if you aren't sure, just throw some absolute value bars on there, that'll help. Okay, now that's 1 point, but the other point will be getting the limits right, and that's these numbers here. The smaller one goes on the bottom, and the bigger one goes on the top. So since this is integration with respect to x, we use the x values. All right. Now, when we're integrating with respect to y, we've got a little bit more work to do. Okay. So what is that extra work? For these ones, we need to change these equations. So y equals 3x, we have to get the x by itself. So that equation becomes y over 3. And my other equation here becomes the square root of y. Now, technically, whenever you take a square root, you get a plus and a minus, right? Now, the minus represents the left half, and the positive represents the right half. Now when you look back at your graph, though, we were working on the right half. I'll bring it back to you real quick. So we only want the right half, so we're only going to take the positive square root number. So that being said, let's get back there. So I'm not going to use the negative one. I'm going to use the positive one. Okay, so I'm just going to cross that one off because we're working on the right half. All right, so now we're ready to begin. So now, remember, with these kinds, it's instead of top minus bottom, it's right minus left. Now, you guys don't need to write that on your actual quiz or test that's coming up, quiz I mean, but I'm just writing it for note's sake here. So the one that was on the right was the square root of y, and the one that was on the left was the blue one. That was y over 3. But once again, if you're insecure about that, absolute values are your friend. Now it's important that you put a dy here, and the other big difference is the fact that the numbers that go on the integral now are these numbers, the y values. So we're going from 0 to 9 this time. Now believe it or not, we're not going to do this, but this is enough. But believe it or not, these look completely different. But if you were to type these into your calculator, they both give you the same exact answer because they're just two different ways of finding the area. It's just one you're integrating with respect to x, the other one you're integrating with respect to y, but either way you're just adding up all the area and putting it together. It's the same shape, so you get the same area either way. All right? So for these problems, you don't actually need to write down the answer of the area, you just need the setup. And so for this guy, it's pretty much just the integrand with the dx and then the limits, right? For this one, did you get the y's by themselves correctly? Okay, so a lot of these questions, there's one that I'm kind of concerned about for you guys, and so here's some extra notes for this problem that might help you. I'm going to give you guys some extra types of equations here that you want to make sure that you know how to solve for. Okay, so let's say that I gave you this, and I asked you to get the x by itself. Well, the way that we get the x by itself is first by getting rid of the e, and we do that by taking ln on both sides. So ln of y equals ln of e to the x minus 3. And what happens is these cancel each other out. So I'm left with ln of y equals x minus 3. And then we would just add the 3 over to the other side. And we would have x is equal to ln of y plus 3. Okay, so if you don't know how to solve equations with an e in it, that's how you do it. Another one that you might want to be aware of is, suppose I had this. I always draw my ln's like that. X plus 4, right? Let's say we had that equals y. Well, in this case, we need to get rid of the ln. And the way that you do that is by exponentiating both sides, which means you make both sides of that original equation a power of e. Okay? And what happens on the left is these cancel, and now you're left with this. And finally, to get the x by itself, you would just minus 4. So keep that in mind. You may see an equation like that on your quiz, wink, wink, or not. But those are possibilities. So let's go ahead and move on to number 5. All right, so this is our last one, and this one's a doozy. It's worth 3 points. This is one that I don't want you to use your calculator for. Now, you can use your calculator because you're going to be using your calculator for the rest of the questions on the test. The problem is that you still have to show all the appropriate work. Okay, so you're going to get 3 points. You get 1 point for finding the intersection. You get 1 point for the integral. And then you get 1 point for the answer. Now, I'm not going to be able to squish it all in here in one space, so I will have to do each one of these steps separately and erase as I go. There's a lot of space. This one will take you probably the most time, but that's how the points are going to be divided up. You get 1 point for finding where the two functions intersect, 1 point for writing out the integral appropriately, and 1 point for actually getting the final answer. And that's it. So, without any further ado, let's get started here. So the first step is to find where they intersect. So I have 2x cubed plus 2x squared minus 3x plus 1. And I have x cubed plus 2x squared plus x plus 1. And to find where two functions intersect, we just make them equal to each other, and we solve. So the first thing I'm going to do is minus this x cubed on both sides. And I'll also minus the 2x squared on both sides. And I'll minus the x on both sides. And I'll also minus the 1. And let's see what comes out as a result of that. So everything on the right side is gone now. And on the left side, I've got x cubed. Those are gone. These become minus, looks like 4x. And then these are gone. So I've got that. All right, the next thing we're going to do is we're going to solve this equation. So how do we do that? You're going to factor. So I'm going to start by taking out an x. And then this is a difference of squares. So what times what makes x squared? And what times what makes negative 4? And then you're going to set each one of those pieces equal to 0 and solve. So we have x equals 0, we have x plus 2 equals 0, and we have x minus 2 equals 0. And we solve all of them. This one's done. For this one, we get negative 2. And for this one, we're going to get positive 2. So I've got 3 intersection points here. 3 intersection points. Now, will your quiz have 3 intersection points? I don't know. Maybe it will, maybe it won't. It might just have 2. Okay? If there's just 2, then you're only going to need 1 integral, a starting point and an ending point. But if you have 3, you're going to need 2 integrals. All right? So let's continue. So that would be 1 point, finding those places where those lines cross. All right, now the next part is to set up your integral. All right, and that's what those intersection points were for. So my first intersection was negative 2, that's the smallest one, and then 0 would come after that. But after that, we're going to need another integral. The other integral is going to pick up where that last one left off, and it's going to end at the other intersection point. So I'm going to have 2 of those. All right. Now, I need to write out my integral. Now, on this one, you're not allowed to cheat and use absolute value because when you're trying to integrate a function by hand, you can't have absolute values. So on this one, you actually need to know which one comes first. That is important. So how do we do that? Well, you're going to pick a number between these two numbers, and then you're going to plug it into each one, and you're going to see which one's bigger. The one that's bigger will come first, and so that's how we do it. So what's a number between negative 2 and 0? Well, that would be negative 1. So I'm going to be plugging negative 1 into each one of these functions here, so bear with me for a moment. And we're going to simplify. So this piece here becomes negative 2. This piece is plus 2. This piece is plus 3, plus 1. These cancel, and I get 4. So whenever I plug in negative 1, this function gives me a 4. So I'm going to go ahead and write that down here so I don't forget. Now let's plug in negative 1 to this one. So this piece is negative 1. This piece is 2. And those are negative 1 and positive 1. So these just cancel, and these combine to make 1. And so this function over here comes out to be 1. I think it was, right? I think it was 1. So as you guys can see, this one is bigger than this one. 4 is bigger than 1, right? So on this interval from negative 2 to 0, we chose negative 1. And on that interval, it seems like this guy came out to be bigger. And so that's the one that's going to come first. try to squish it in there. I might run out of space. Let me see if I can move this over a little bit. I can. Nice. Okay, so there's that one, dx, and then plus, and now we're going to repeat this process for this other integral over here. All right, so now I would say 9 times out of 10, this one's going to be opposite from this one. So in other words, if this one came first on this integral, then on the other one's going to come first. But if you want to be safe, just to check, you can. But because there is a rare circumstance where that won't happen. But for the most part, it will. So let's begin by picking a number between 0 and 2, and let's plug it in to the first function. So if I plug in 1 here, I get 2. Here I get 2. Here I get -3. And here I get 1. So combining all these, I end up with 2 as a final answer. Let's plug in 1 over here. That would give me 1, and then 2, 1, and 1. Putting all that together, I get 5, and sure enough, as you guys can see, now the one on the right is the bigger one. And so for this over here, we're going to do x cubed plus 2x squared plus x plus 1 first, and then the other function second. Now, this is your second point, is actually getting your integral set up, okay? So did you get this piece? That would be your second point for this problem. The rest of the credit, the last point, goes into solving this, okay? So let's go ahead and begin the solving process. The first thing I'm going to do is I'm going to simplify these. I'm going to distribute the negative here, and then I'm going to combine all my like terms. So by distributing the negative, the x cubed will become negative, this 2 will become negative, this x will become negative, and this 1 will become negative. And on this other one, we're going to do the same thing. We're going to distribute the negative, and all those will change signs. So the 2 will become negative, this 2 will become positive now, this 3 will become positive, and this 1 will be negative. And we can go ahead and cross this out, make it a positive, like that. All right, so now we're ready to combine our like terms together, so here we go. So my first integral that goes from -2 to 0, if I put my cubes together, I'm going to end up with x cubed. If I put my squares together, they're going to cancel. If I put -3x with negative x, I get -4x. And if I put +1 with -1, they cancel. So there's that. Okay. Plus, now we do the other one. This one goes from 0 to 2. If I put this x cubed with this -2x cubed, I get -x cubed. This 2x squared and this 2x squared are going to cancel. Positive x and +3x makes +4x. And then +1 and -1 cancel. Now, just so you guys know, this should happen every time where, so long as these were opposites, this and this should be opposites. Notice that on the left, it's a +x cubed and a -4x, and on the right side, they're complete opposites. It's -x cubed and +4x. So they should be the same thing, but just opposite signs. Now, once again, you may not have the situation where you have to set up 2 integrals on your quiz. It may be like that, or it may not be. If you end up with 3 intersection points, you'll have 2. But if you only have 2 intersection points, then you're only going to have 1 integral. Okay, let's move on to the next step. The next step in solving it is to actually go ahead and integrate. So what is the integral of this? Well, if I integrate that, you add 1 to the power and divide by that number. Same thing here. If I add 1 to the power and divide by that, I'm going to get 2x squared. And this one goes from -2 to 0. And this one over here should be the same exact thing, obviously, just opposite signs. Because it's the same function, it just has opposite signs. So this one's going to be -x to the 4th over 4 plus 2x squared. Okay. All right, the next step in solving these I would say want to make sure that you're neat in how you're setting up this next step. You're going to make two big pairs of brackets, one for each integral, and you're going to do two sets of parentheses being subtracted in each set. And then you're going to start plugging stuff in. So we're going to plug in the 0 first. So that's going to be 0 to the 4th power 0 over 4 minus 2 times 0 is just going to be 0, so that. Then we're going to plug in negative 2 for the next one. Negative 2 to the 4th power is 16, and 16 over 4 is 4. And then minus, plugging in 2 to this next one here, negative 2 squared is 4, and 4 times 2 is 8. There's that. Repeating the process here, you're going to get negative 16 over 4 is negative 4, and plus 8. And then plugging in 0 here is just going to make the whole thing become 0, just like it did on the other side. All right, so we can ignore that. That's all just 0. Let's distribute our negative here. And then we're ready to go ahead and put all this stuff together. So we have negative 4 and 8. That makes positive 4. Negative 4 and 8 makes positive 4. And that all up makes 8. So there's our final answer. There's your last point. Okay, and that's that. All right, so hopefully that was a helpful study guide help video for you. We'll see you guys in class and see how well you do. See you then.